Assalamualaikum and good day to our respected lecturer, Dr. Adenin Afifi binti Nawi, and to our fellow friends. We are from Group 9, Section 2. Today we are excited to present our project-based learning assignment for the course DAC11402 Algebra for Semester 1, Section 2025-2026. Before we begin, let me introduce our team members. First, myself, Muhammad Amirul Shazwan, Muhammad Farhad Arif, Muhammad Arif Haikal, and Hadi Haikal. Together, we have worked applying algebra sequences to real-world scenario. Our presentation today is divided into 8 main parts. We will start with an introduction, followed by the case study statement. Then we will dive into the problem solving and our solution method, which is include both manual calculation and Excel. Finally, we will share our task distribution, reflection, reference, and the rubric. Let's start with the basic in algebra. We focus on 2 type sequences. First, arithmetic sequences. Second, geometric sequences. Arithmetic sequences, where the difference between consecutive terms in constants. D. Geometric sequences, where the ratio between consecutive terms in constants are. They are not just numbers on page, but they are widely applied in finance, engineering, and construction to help us predict future values. On the screen, you can see the formulas. We are use the n, th terms formula and the sum of n terms for both arithmetic and geometric progression.
Hi and Assalamualaikum. My name is Muhammad Arif bin Muhammad Rafi. My matrix number is AA251286, and today I'm going to talk about our proof meeting and task distribution. For the proof meeting, our group using online platforms such as Google Meet and also video call. And for the task distribute, for this project, our group worked together and divided the task equally. Each member has a responsibility for different part to make sure the work was done smoothly. One member focusing on preparing the introduction and the background of arithmetic and geometric sequence. Another member handled the case study and the problem understanding. For the calculation and the problem solving part, including the manual method and also the Excel solution, we share among the members. And then lastly, one member has compiled the report, checked the format, and prepared for the presentation slide. By dividing the tasks, we are able to manage our time better and complete the project effectively as a team. And the second one is case study statement. This case study is about installing street light on the bridge to ensure the proper lighting and safety. There are 2 different lighting plans are proposed to decide the spacing between each lamp. So there's a plan A and plan B. The plan A using an arithmetic sequence when the distance between the lamp posts increase by 2 meters starting from 2 meters. And the second plan is which is a plan B, uses a geometric sequence when the distance between lamps posts increase by 50% each time. And also it starts from 20 meters. The purpose of this case study is to compare both plans and see how arithmetic and geometric sequence affect the total of distance and design of the bridge light system. Now, let's move to the next part, which is the filler table. Filler table stands for fact, ideas, learning issue, and also the action. For the first fact is street lights are installed along a bridge, and the idea is use sequence to model lamp post distance. And the learning issue is how to identify arithmetic and geometric sequence. And the action is analysis the given information. And the second fact is first distance between lamp and post is 20 meters, and the idea is applying arithmetic and geometric sequence. And For the learning issue is formula of the nth term. And the action is write the nth term formula. Third fact is distance increased by 2 meters in a plane A. So the idea is use the arithmetic sequence. But the learning issue is to find the formula total distance. And the action is use sum of arithmetic sequence. And the fourth one is distance increased by 5% in plane B. And the idea is using the geometric sequence. And the learning issue is how to calculate geometric growth. And the action we should use is use sum of geometric sequence. And the last one is first, fifth lamp course are considered. So the idea is compare both of lightning plans. Learning issue is which plan covers more distance. And the action we should take is calculate and compare the result from arithmetic sequence and also the geometric sequence.
So the first one is a arithmetic progression. So it is mentioned that in the first plan, the distance between the lamppost is increased by 2 meters, and the first distance is 20 meters. We can conclude that the first term is 20 meters, that is equal to A, and the common difference are 2 meters. So if we put it in the formula, it is written as xn equals to 20 plus with n minus 1 times with d. So for the second question, we have to find the total distance covered for the first 15 lampposts. So the formula are written like this: Sn equals to n over 2 in bracket 2a plus n minus 1 times with d. So we have to put our terms, that is n equals to 15, and the common difference are 2, and the first term is 20. So we put it in a calculator, that is equal to 15 over 2 times with, in bracket, 2 times with 20 plus 15 minus 1 times with 2. So that we get 15 over 2 times with 68, and the answer will be 510 meters. So for the second plan, it will be using the geometric progression, and we can return that the common ratio are 0.05 or equal to 1.05. It is because the common ratio are increasing, which is the first term is 100%, and we have to plus with 0.05 as the common ratio, and also the first term are 20 meters. So if we put it in a formula, the formula will be xn equals to 20 times with 1.05 power of n minus 1. So the second question is also the same. We have to find the total distance for the first 15 lamp, and as we know, in geometric progression we have two types of formula, which is r, our ratio is either bigger than 1 or less than 1. So for now, our ratio are 1.05, which is bigger than 1. So that our formula will be A times with r power of n minus with 1 over r minus 1. So that the sum of 15 terms are equal to 20 times with 1.05 power of 15 and minus with 1 over 1.05 minus with 1. That we can get 21.58 and over it to 0.05, and the answer for the common ratio, the answer for the geometric progression to sum of 15 is equal to 431.6 meters. So the next one is the Excel method. So the first one, we have to put the n term first. As we know, we are looking for the 15 term, so that we have to jot down from the first term to 15 terms. And the second column, we have to put the formula and also the answer to each of the term. Like the first term is 1, then the formula will be 20, equal to 20, and After that, we can select all the column from the formula until the 15 terms, and we can put it as a sum. So as shown, the sum is equal to 510. So for this geometry, also the same. We have to put the n term from 1 to 15, and we have to put the formula on the second column and make sure that we have calculate it right, so that we can select the box from top to bottom to calculate the sum of the geometric progression for 15 terms. So the answer will be 431.58, and we can round off that to 431.6 meter. As shown, the graph are being plotted.
Hi, I'm Farah Arif. My metric number is AA250386. I'm gonna present about my part, which is reflection. Through this case study, we learn how arithmetic and geometric sequences can be applied to real-life engineering situations. We gain a better understanding of how small increases in distance can significantly affect the total length of a project. By using Excel help us visualize the data more clearly and compare both plans efficiently. This activity improves our problem-solving skills, mathematical understanding, and ability to connect theory with real-life engineering applications. These are all the references that we use for our project. Thank you.